Alrighty, hopefully you watched the first video. I gave you the code right in there, which was inscribed angles. We stopped right at the homework. So I'm going to show you the answers to the homework. And you can pause the screen so that you can actually see what those answers are. Let's see. Try and get it so you can see all of it. There we go. All right, so this was that circles, homework 5, inscribed angles. Oh, there's the code word. But here's the answers. If you have questions on how I did them, you can message me on Remind and I can have a detailed description on how to do that. So if you want to look at these answers, pause the thing. I'll read them off really quick. Number 1 was 176. Number 2 was 17 degrees. Number 3 was 59 degrees. Number 4 was 105 degrees. Number 5 was 54 degrees. Number 6 was 73 degrees and 73 degrees. Number 7 was 79 degrees and 112 degrees. Number 8 was 89 degrees and 123 degrees and 91 degrees. And then lastly, 9, 10, 11, and 12. Number 9, x equals 9. Number 10, x equals 2. Number 11, x equals 23. And number 12, x equals 11. So once again, if you do have questions on any of those, just make sure that you ask me on Remind so I can explain them for you. Alrighty, tangent lines. Okay, so for tangent lines, this is page 4. We are starting with a tangent line. So a tangent line intersects a circle at exactly 1 point. So right there, I want you to write 1 point. And it's called the point of tangency. So if we're looking at the circle right here, the point of tangency is going to be A. Okay, it's a point, so it's only one letter. A point of tangency, A. All right, a line is tangent to a circle if and only if it is perpendicular to a radius drawn at the points of tangency. Okay, so perpendicular, what does perpendicular mean? Think of 90 degrees, okay, see in this picture. We know that this line AB is perpendicular to angle, or to radius AP, because there's that 90-degree angle there, okay, to a radius. All right, so anytime we see 90-degree angles, you might want to think that triangles are going to come up, because they will. Okay, so the first thing that they want us to do is determine if this line is tangent to the circle. Okay, the way to do that, we know that it's circle P. Okay, this point here is the center. Okay, the one in the center of the circle is called the center. All right, so if that's the center, okay, that means that this right here is a radius, AP is the radius. Okay, and AB, we're trying to prove that that is the tangent. So how can we prove that that's the tangent? We need to make sure that it's perpendicular to the radius. Okay, so we want to make sure that right here, right at angle A has to be 90 degrees. That is a 90 box I just drew in there, and it's not very pretty, so let's give it a second whirl. Oh, just as bad. All right, so that's a 90-degree angle there. Okay, so you see a triangle, you see a 90-degree angle, and you see 3 lengths for the sides. What do you think we're going to be using? That thing I told you you're never going to get rid of. Pythagorean theorem, a squared plus b squared equals c squared. Okay, remember a and b are the legs, our c is the hypotenuse, or the side across from the 90-degree angle. Okay, so we're going to do, to prove that that's 90-degree angle, we need to make sure that a squared plus b squared does in fact equal c squared. Okay, so we're going to do 8 squared plus 15 squared equals 17 squared. If this comes out not true, so if 8 squared plus 15 squared does not equal 17 squared, we proved that it is not tangent. Okay? If it does come out equal, it is tangent. Okay? So let's do that in our calculator. I don't have mine up here, but I'm going to just use my phone. 8 squared is 64. 15 squared is 225. 17 squared is 289. Okay, now we're just going to do, it's 289. That 9 will show up shortly. Now we're just going to do 64 plus 225. And we get 289. Does 289 equal 289? It does. So yes, it is tangent. All right. I want you guys to try number 2. Pause it, try number 2. All right, hopefully you paused it and tried number 2. Okay. Remember, we want to determine if B or AB is tangent. So we want to make sure or prove that this is a 90-degree angle. Okay, so we're going to do 11 squared plus 14 squared. This one was a little tricky. Okay, this whole side is not 5, just this little piece. What's this piece here? It's also a radius, isn't it? Okay, so if this is the radius and this is the radius, okay, the radius is always going to be congruent within a circle. So what's the length of BP? It's going to be 11 plus 5, which equals 16. Okay, that says 16. So BP is 16. So we're going to do 11 squared plus 14 squared and see if it equals 16 squared. All right, 11 times 11 is 121. 14 times 14 is 196. And so we're going to add those together. 196 plus 121. We get 317. And then 16 times 16 equals 256. Do those equal each other? Does 317 equal 256? No, it does not. Okay, so that is not going to be tangent. So this one is a big fat no. Okay. All right, these questions, okay, all they're saying, okay, is we're going to do the same exact thing, except this time they're telling us it's tangent. So all we need to do is 7 squared plus 19 squared to make sure it equals this squared, okay, or different variations of that. So on this one, our right angle should be, you want to make sure you put the right angle in the right spot so you can set up the problem right. Right angle is going to be the tangent line, okay, and it actually tells you JK is tangent. So the line and the radius make up that 90-degree angle. Okay, so we're going to just do in our calculator 19 squared plus 7 squared equals x squared. Okay, so 19 squared equals 361. 7 squared is 49. So 361 plus 49 equals 410. So we're going to square root, take the square root of that. Square root of 410 is going to be, square root of 410 is 20.248, blah, 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 blah. So we're just going to say x equals 20.2. We're just going to round to the 10th place because that's all I want to do. 20.2 is what x equals. All right, number 4. All we're going to do is make sure that we set it up correctly. Okay, so our 90-degree angle is the tangent line and the radius. So JK and JL have to be perpendicular, so our 90-degree angle is right there. So this time we're going to set it up. X squared plus 11 squared equals 7 squared. Okay, I already know that 11 squared is 121 and 7 squared is 49. Okay, so I'm going to do 11 squared, or 49. Oh, once again, it's not 7 squared. Sorry, I almost missed it. Okay, this part's 11 and this part's 7. So 7 plus 11. LK equals 7 plus 11. So LK equals 18. That's an 11. It does not, that looks like a 4, but it's not. Hopefully that's better. 7 plus 11 equals 18. So this part here is 18 squared. All right, 18 squared. 18 squared is 324. And 11 squared is 121. So we're going to do 324 minus 121. We get 203, and we're going to just take the square root of that. We get 14.2 as our answer. Hopefully that wasn't confusing. All right, I want you to pause it and try 5 through 9. When I finish, I'm just going to show you the answers. Okay, I'm not going to go through it. If you have further questions on it, you can just ask me, all right, through your mind. All right, hopefully you did those. Number 5, you should have gotten x equals 16. Number 6, you should have gotten x equals 11.9. Number 7, you should have gotten x equals 9.5. And number 8, you should have gotten x equals 12. And number 9, you should have gotten x equals 15. Okay? Hopefully you got those right. If you didn't, no big deal. Shoot me a text and I will help you out. All right, more tangent line properties. So this one's actually pretty easy. Okay, all you need to do is set them equal to each other. Okay, so two segments from the same external point. Okay, so see how they're two tangent lines and they're meeting at one point. Okay, that means that they're going to be congruent. So AB is going to be congruent to BC. Easy enough. Okay, the little dunce hat is going to be congruent. This is going to be congruent. And if a polygon is circumscribed around a circle, then all sides are tangent. Okay, so the sides are going to be tangent. Okay, so we're going to apply this rule to this. Okay, so we know that on this one, let's draw this. So this is congruent to this. Those are tick marks that are very thick, so we're going to make them thinner. This is congruent to this. You know, this is congruent to this. This is congruent to this. And this is congruent to this. All right, hopefully that wasn't that confusing. I'm going to actually use highlighter because that might be better. So this and this are congruent. This piece and this piece are congruent. And this piece and this piece are congruent. Okay, hopefully that helps. All right, so let's try this. All that we need to do to solve for this is set them equal to each other. Okay, so all we're going to do, 5x plus 23 equals 8x minus 19. Combine, add 19 to both sides, subtract 5x. We're going to end up with 42 equals 3x. Divide by 3 on both sides. And we're going to get x equals 14. Okay, same thing for number 11. Except this time they don't want us to find x, they want us to find PQ. So pause this, try and find PQ, or at least x. All right, hopefully you paused it and tried it. We're going to set these equal. 14x minus 13 equals 8x plus 5. Oh my goodness, it's not coming out pretty. All right, 8x plus 5. We're going to subtract 8x on both sides and add 13 on both sides. 14 minus 8 is going to give me 6x. Add 13 to 5. We're going to get 18. X is going to equal 3. But it asks for PQ. So we're going to plug it in. 14 times 3 is something. 42. And 42 minus 13 is going to give me 29. Oh. Hold on. 42 minus 15, yes, 29. Click to add instead. Is your answer. All right, on this one, all we need to know about it is that if those are congruent, these are triangles, this is congruent to itself. So these triangles are congruent. So SV or VU is going to equal 17. Now we just need to use the Pythagorean theorem. I'm not going to test you on that. But if you want to try it, go right ahead. You know how to do it. I'm going to give you the answer. You should get X. Let's see. You get X equals 8, in case you're wondering. ST is going to equal 39. Once you find that, we need to find SV. SV is just you're gonna use the Pythagorean theorem and get SV equals 42.5. I'm not gonna show you to do that because it's not that important. All right. Last two on this part. All right, find the perimeter of DEF. DEF is right here. Okay, we're going to apply those rules. Okay, we know that, let's use the highlighter. This is congruent to this. We know that this is congruent to this. And we know that this side is congruent to this side. Okay, so if that's 16, this is 16, this is 9.5, this is 9.5, and that's 11, this is 11. Okay, so now we just need to figure out the sides. DE is just going to equal 11 plus 16, which is going to be 27. Okay, FE, okay, is just 16 plus 9.5, which is going to be 25.5. And DF is just going to be 11 plus 9.5, which is going to be 20.5. Okay, and it wants us to find the perimeter. So we're just going to add all those together. 27 plus 25.5 plus 20.5 equals 73. So our perimeter is 73. All right, last one on this page that I'm going to go over. All right, find the perimeter. All right, of quadrilateral PQRS. All we're going to do, we know what's congruent. Okay. If all right, so this is 27. We know that this is 27. Okay, which means that that blue piece is 52.5 minus 27. Okay, so 27.1. All right, so 52.5 minus 27.1 equals 25.4. All right, so we know that space is 25.4. So I'm going to highlight in blue. I'm going to highlight that piece in yellow. So know that that's what that equals. All right, so that equals 27.5. Put that there. All right. So if that's 25.5, we know that PS, so we want to find, we've got SR, it's 52.5. PS is 23 plus 25.5. Which is 48.5. So that's PS 48.5. Okay, we know that's 48.5 because this blue part right here is 25.4 and this piece is 23. So all we did was add those. Okay. For this part, all we need to do to find QR, okay, we know that 37.5, I'm going to erase this part down here. All right, 37.5 minus 23 equals 14.5. Okay, because we know that if this is 23, we know this is 23. So all we're doing to find out what the length of red is 37.5 minus 23 gives me 14.5. So that's the red part. All right, last we need to find this right here. Okay, so if the red part is 14.5, okay, all we need to do is 37.5 minus that 14.5. That'll give us that last piece there. Sorry if you lost me. I know this is confusing. So this part right here is going to be that 37.5 minus the red 14.5, which equals 23. So that's going to be your green. It's at 23. Okay, so last piece that we need to do, I'm going to do it all off to the side right here. We know PQ equals 37.5. We know QR equals 27.1 plus 23, which is 50.1. We know that RS equals 52.5, and we know PS equals 48.5. So now all we need to do is add all four of those together. 37.5 plus 50.1 plus 52.5 plus 48.5 equals 188 point. I think I added that wrong. Hold on. Nope, looks good. So we get perimeter. All right, 37.5 plus 50.1 plus 52.5 plus 48.5 gives me 188.6. All right. So what I want you to do is come back so we can finish those other 3. Remember, code word is still going to be inscribed angles. I'm just going to leave it the same. You can watch the last video or not. It's up to you. But yeah.